So let's create a new project. Let's go and then say new immersive room. Create project. And here I want to create a panoramic. So I'll create a screen, cylindric. I'll make it 180 degree left and right. So we have a 360 coverage, make it a bit bigger, example 6 meters, and let's leave the height as is. So a cool feature about our software is you can not only add projectors like we did earlier, one by one, and then cloning and moving them, but you can deal with projectors as a group or as an entity. That means circular arrays or linear arrays. So here, if I add a projector and I add in quantity, I increase it to, for example, 5, I can choose a linear arrangement, so side by side, or a circular arrangement with a defined radius. For example, here, 3 projectors with a radius of 3. And then I'll add another barcode, for example, G50, 7th, this one. So here we get a grid that is already in the scene with all our projectors. And now we can see how we control them all at once. Well, first we wanted to face outward, fill the room. Second, the radius is too big. So let's make that 2. So now we start to covering a bit more. Here we are stretching too much on a curved surface. So it's actually interesting to add more projectors. So if I click add projectors here, projectors automatically add up. And if I click remove, then it removes projectors. This all while staying in this grid layout with controlling the radius, the arc, and I can move this whole group together. I can offset it here, regenerate my truss, and it's all considered as an entity. We put this back to 0, so 3 meters height, 0 here, 0 here. So we are centered in the room, right? And then from here, we can manipulate all the projectors together. So we can either change, as usual, the lens. So we go with a 0.65 lens. Then we need to add a bit more projectors. Add projector. Add projector. Now we start to get some good overlap. I can reduce the radius to, let's say, 1.7 to get more distance from the screen and therefore more overlap. And I can shift my projectors up and then control all the projectors to shift down. So I go to my projector data and I do a vertical shift down. Now we see the whole scene moving down. Then with my cylinder, then I can shift it up to cut directly until the overlap, and then I can reduce the height of my screen until it's perfectly where I want it to be. And then here I optimize the coverage of the projectors so that all of them are in the screen and that my screen is actually all used. We add the reference human as usual. And there we have very quickly a nice symmetric to a top orthographic view. So here we have a nicely satisfying symmetric setup of a quick immersive room with a projector layout. But that said, you can also manipulate the projectors individually. Let's say here you have a door and you can open this circular array and you can select one single projector like this one. And if you want it physically to move, then you can move it and the rest stay inside the grid. So you're not tied up to this concept of grids and layouts. It is in your advantage. It helps you start. It helps you get a good starting point. And then you have individual control over each projector like everywhere else in the software. So that's it. Here then we can run a couple of analysis. So let's run a brightness analysis with overlap. So here we see the results. And if we move our whole grid closer a bit to this side, generate truss, and we redo the analysis, then we can see here on this side, it's brighter. So we are higher on the heat map scale, and on the right side, it is darker. That's because our grid is not perfectly centered in the room. So we have the feedback visually, and we can correct it. Similar as earlier, warp and blend, we saw already projector coverage. we have it. And then camera coverage here is interesting because we can add a fisheye camera. That's we usually do for immersive rooms. So this is my fisheye. I can rotate it minus 90 degrees. Through x-axis, minus 19. So that it points down, and then I can view through that lens, see the projectors. Here I have a strange behavior, probably did too much. I'll just save and refresh the scene. Get a fresh view. So here's my camera view again from the lens. So then we see everything. We see the obstacles that are projectors. So we need to go lower with the camera so we can scan. That's the coverage for our fisheye. And we can see also the obstacles here for the projector bodies through the lens. So let's say that we're not happy with the fisheye and we want to go with multiple cameras, then I can add a camera here that is a normal perspective camera, quickly point it up to a side of the screen, and then I can run my camera coverage analysis. So from here, the view, I see it covers one projector and two halves, but it's not exact knowing how many, for example, dots we cover. As you know, our calibration algorithm project dots, and based on that, we calibrate the projectors together. And when I place a camera, then I can see approximately how many portion of the screen am I covering. And if I duplicate and create another camera, then I can see also my overlapping coverage. So I point roughly this camera to this side of the screen, run the analysis again, and now I have in the analysis two colors. So light blue for the left side, purple here, and I have a camera overlap in green. So then I know when I do a layout of multiple cameras, how much I can cover, where my coverage is overlapping. So that's not also a concept for projectors, but when you do camera calibration, it's very useful to have this as well for cameras. Other parameters I will let you explore because we're running out of time, like pixel density, projection quality. This is for the incidence angle. If you have projectors that are too perpendicular to the normal of the surface, then we can detect that also, and we can have a quality metric, a quality score to the projection, and decide if it's good or not. So far, let's see if I missed something. Yeah, we have quickly go through our measurement tool. So you can snap to the projector lens output and measure here. You can do also a chain measurement. So distance between all lenses, for example. So this works and snaps quite nicely. Annotations, of course, we can add an eye point, so we see which area is covered, and we can view it through an ATOF plot. So here we're looking straight at the human model.
There was a question also in the chat, Ahmed, thank you for showing this, but we have eye-dependent analysis. We have also a couple pictures about pixel density. Can maybe show this again?
Yeah, pixel density. So we don't have it yet related to the eye point. So now it's pixel size per meter, or we have the pixels per meter. So that's density, or the pixel size in millimeter of the setup. And in the future, we will share the roadmap later. We will have eye-dependent metrics like resolution, arc minute OLP, so optical line pairs viewed from that eye point. Is that pixel too big or not? Is that area high in resolution or not? So that's something we definitely lay the basis for in our software with our eye point and analysis logic. Yeah, I think that's it from my side on the list, at least on the two in-depth projects.
You did an absolutely great stuff, Ahmed. There's a lot of stuff you can just hear, you know. It's let's give an applause for Ahmed, you know. I know it's a lot of stuff, Ahmed, that you went through, but it also shows you how much thought we put into this one. And you see, you get clapping hands now. Wow, Ahmed. I think something that we need to clarify is how to export things, you know?
Yeah.
So I will help you with through, but maybe you can show already that how you can export it to, let's say you work with Vectorworks and you want to export it as an OBJ. Maybe you can show this path one time.
Yeah, so that's the report and export side of
Or
the
you
software.
want me to take it over? I can do,
It's
but
all
then
here. No, it's fine. Since I'm sharing my screen, I can quickly run through it. So I planned about 5 minutes for it. So let's say export to. So we have classic export formats like our own format, exchange to other third-party software equipment list, but you can also export the scene as a mesh, which is quite useful if you want to take this planning quickly somewhere else to do the validation for the mechanicals, so projector mounts, etc., and then feed it back to the software to do validation. This is usually the workflow we do for sites. Then this is useful.